You don't have it in your fingertip. Where's the solubility memorization thingy?
This is the solubility.
That's not the solubility. That's oxide. That's salt preparation. Where's the solubility? Good. No, this is preparation. This is, I think, preparation, right? So again, where's the solubility? Oh, dear me. Right. Okay, dear me. Right. Okay. You truly you don't have time to waste. Go find it in your other chem Jamboard quickly. You go to the Jamboard, you search chem and then go and find it. We did it. We did it.
Oh, you mean the one on my notebook? Oh, yeah, I have that.
Maybe. Yeah, maybe. Yeah, show me. Yeah, maybe you wrote it there. Sure.
Oh,
This is not solubility. This is not solubility. This is not solubility. There you go. There's solubility in front of you. So what does it say about oxide?
It says that any oxides with group 1 and 2 metals will precipitate.
Okay, so copper oxide?
Copper could. No, it will not precipitate.
So now D.
So it should be true.
Okay, check the answer just to mention.
It's
just
false.
to confirm. What do you mean by true, false? What do you mean?
My answer was true, and the answer said it's false.
You mean A is, sorry, what's the answer? True, false, true, or what?
Yeah.
So you're right, like true, false, true. No?
No, I said 9C was true.
How do you read your solubility table?
Where's copper?
Any oxide will precipitate except group 1 and group 2, right?
Yes.
So copper?
1 or group 2.
If copper is group 2, I don't think they need to put the 2 there.
Oh, so it is
because
group
2. It is not group 2. You do not know that copper is not group 2. Please check your periodic table. Please check your periodic table right now.
Copper is group 11.
Whatever that is, yeah, but it's not group 2.
Oh, okay, so just strictly group 1 and group 2.
That's what your notes say.
All right.
Okay, so true, false, true. All right.
Yes.
What bothers me a little bit is that you don't consult this. That bothers me a little bit. While you were doing it yesterday, right? Everything clear?
Yeah.
Now, needless to say, you'll be needing this memorization tomorrow, and it won't be in the form that you see. It won't be nice like this 9 A, B, C, D. It will be used inside other questions, right? That's what you should expect, right? Okay. Yeah. Your next problem will be?
I don't think I have any more problems.
Right. Have you done another? Okay, this is only paper.
Yeah.
Cool, right? Have you done the paper one?
No, I haven't. You said I should do paper 2, right?
No, I said you should do 2 sets of paper 1 and paper 2.
Oh, okay. No, I just did this.
Really? That is the only thing that happened today?
No, I did the memorization for everything except acid bases.
And oxide. There isn't much other memorization.
I mean, no, there's drying agents and then upward, downward, everything else.
Okay, so you should do the oxides and the acid base and salt preparation, right? The one that we just used. All right, but not now, not now. No, not now. Okay. Oh dear. The preparation is, I don't think is enough. No? So let's do our best. Yeah. Now, I don't think you're ready for a blind paper yet.
I think
Sorry.
I think I can.
As you wish. Right? You don't have much time now. As you wish. Do whatever you can, right? Right. So shall we go? Shall we go ahead and do it?
Okay.
Are you looking at a paper?
Yes. I'll do 2020.
Sure. Do you have a paper to do it?
Yeah. I'll send it to you now so you can see.
All right.
Should I send the answers as well?
No need. You can refer to it yourself. But no, you're doing it blind, right? That's what you want, right?
Yeah.
But like it or not, tuition, watching you doing question is not, not the most helpful thing for you, lah, right? So my suggestion is something like this. So when you do and you really cannot, we better just discuss, lah.
Okay,
right?
sure.
And then when discussion, then you want to check the answer key, right? For you, per question, I think you need to see the answer key per question after you do, because then you will catch any mistakes and we can discuss. No? If you wait until you finish and then you check the answer key, tuition will almost, the tuition is done by then. Right? So you don't have to send me, that's for you, right?
Okay, sure. I'll just send the question paper then.
Sure.
Okay, thank you.
All right. So it's paper 2, right? I am looking at it. All right. Yeah, we read through this, but we just haven't done it. Anish, I'm teaching here. Are we start? Are you doing it on paper or something?
Yeah, we have read through this.
Yep, we have. Yeah, but we haven't done it at all. I was just using it to give you an idea of the topics.
Oh yeah, we have.
So, but can we start? Why are we so slow at starting? Sorry.
Sure.
What are we waiting for? You can refer to the memorization thingy. Right? Um, okay, the drawing page. Right? Gamma is 44.
Okay. What?
Okay, checking the answer, Kira. So your 1A is wrong. Yeah. Before you check the answer key, are you checking the answer key now?
No, there's still a bit left.
D2. There's a D2.
I'm assuming there'll be no difference.
Oh, there is the.
Okay, I'm gonna check that.
But don't check first. So 1A is wrong. I give you 30 seconds to figure out what is wrong. If not, then check the answer.
Okay. From, oh, okay. It's the exact same graph but reversed.
Then do it quickly.
We draw the graph.
Yeah. Right. So please check the answer key. I'm pretty sure D1 and D2 will be
Pardon?
considered incomplete. I'm pretty sure D1 and D2 will be considered incomplete. So please check the answer key for the details.
We draw the graph.
Wait, D2, is it okay? Anything? But D1 definitely incomplete. It's a good idea, but it's incomplete.
I'm trying to check the answers.
Right. So check 1A, 1B, 1C, and then D1.
Okay, that's correct. Slide over 1. moderately together. Yeah. Okay. Oh, 1C is wrong. Bromine is diatomic, right? Why do they only put one molecule?
Yeah, bromine gas is diatomic.
Yeah.
It is. Last time I checked. So
Is the answer wrong or?
let me check again, but he said bromine particles. No, I don't think you should be considered wrong. Right? So let's move on. D1, please.
If you want, I'll just quickly send. I can ask my friends why.
If you could, but please quickly then move on. Okay, D1 shouldn't take a long time. Moving on.
D1. You're right. It is incomplete. Yeah. 2 out of 3.
All right. So what's the missing one?
Against gravity. Which means my D2 should be wrong.
Yeah. The gravity effect is not that much, but it's there. It's there.
Okay. Oh, there's a 1E. I didn't notice.
There is a 1E.
Oh, I wasn't able to. I haven't looked at the answer yet, so I'll do that first. 3 measures per gram. Okay. Physical properties of bromine gas. Do we need to know what's soluble in water and what's not?
You mean the gases?
Yeah.
Most gases that you learn are considered not soluble in water, kind of-ish. Kind of lah. What is more important is usually whether they will react as an acid or a base or not. For example, CO2 will become an acid lah, so it will react with bases lah, for example. When you do the separation, that is to be considered lah. Most of the gases that you know, the common one, are considered not soluble in water.
So, but there are exceptions, right? What are the exceptions?
Ammonia, no. Carbon dioxide, no. Carbon monoxide, no. Oxygen, no. Hydrogen, no. Sulfur dioxide, no. There's a lot of common gases that is simply a no. Helium, no. Nitrogen, no. Oxygen, I said already, right? All the noble gases, no. There's a lot of no's for gases, I guess. Not a lot of gas dissolve in water. Okay. Bromine, I guess bromine dissolve in water, I guess. Bromine.
So bromine does dissolve in water.
Kind of, I guess. It becomes bromine aqueous. Chlorine also become HCl. Bromine and chlorine, I guess.
But those are not gases.
Bromine evaporate very easily. So bromine gas is usually present in room temperature. Chlorine gas definitely is a gas. Definitely.
Chlorine is a gas in room temperature.
Yes.
Yeah.
Bromine is liquid and gas. Yes.
I don't know all of this stuff.
You don't know. Now you know. Right?
Okay, so bromine is liquid or gas, evaporates easily. Chlorine is
Gas, but they both should be considered to dissolve in water. Lah. Consider.
okay.
Okay, I think we cover a lot of the common ones. Lah. So, all right.
So just chlorine and bromine are the exceptions.
Yeah.
Let me write that down. Then what about iodine and
They are not gases. They are not gases.
then F? What's F?
Fluorine. Fluorine. You don't worry about fluorine. This is your least problem, however, I think this is the least of your problem. You should go and do the other question.
Okay. Just to be sure, does noble gases do noble gases exist as diatomic?
No.
Okay, we'll continue. So, let me check the answer. Soluble
Goodness me, there is one E. Couldn't see right now. I realize also.
What is it?
No, yeah, I realized that there is one E also. Right. Okay.
Yeah. Okay. So that's actually not. This is not. This is really
Okay.
one.
Let's move. Let's move. Let's move. Let's move. We don't have time. Let's move.
Chromatography can be used to separate amino acids from mixture obtained from polypeptides. To give one property of the amino acid. Oh, I actually don't know this. What is it? I will check the answer. What's the answer to A? Is it because it's soluble or non-soluble?
If it is not soluble in the solvent yet, he never tell you the solvent, so just say it's a solvent, right?
Mm-hmm.
If it is not soluble in a solvent, will you have the separation? That's a logic question. If you don't understand the logic, you must tell me immediately.
If it's not soluble, what is it?
The whatever you're trying to chromatograph.
I mean, if it's not soluble, then I won't get the mixture. So it is soluble.
Yeah, solubility allows it to be carried and therefore separated by the solvent. That's a requirement for the technique to work. If that makes sense, that's logic instead of memorization.
So that means it has to be soluble
in whatever the solvent that they're using. The solvent doesn't have to be water, just saying.
Okay. Okay. I still don't get it actually. No, I don't get it. I don't get it.
You don't get the logic.
Yeah.
Solubility, meaning amino acid solvent. Okay, let's pretend that the solvent is alcohol. Let's just pretend. Okay, so that you don't think that it must be water. That's not a must.
Okay.
If the amino acid is not soluble in alcohol, well, the amino acid will precipitate, meaning the amino acid will stick with amino acid instead of sticking with the alcohol, basically. Solubility means that the amino acid is stuck to the alcohol, surrounded by the alcohol in the molecular level.
Okay.
If amino acid is soluble in water, the water is surrounding the amino acid in the molecular level, meaning, again, the water is stuck to the amino acid, vice versa, not to each other. Now, again, if the amino acid is not soluble, meaning it chooses to stick to another amino acid, so they clump. Will the solvent be able to carry the amino acid along the paper?
If it's not soluble, no, it won't.
Yeah, because they don't stick. The solvent and the one they're supposed to be dissolved, but they don't stick to each other. That's what solubility means. So how can chromatography work? Because chromatography work by the solvent bringing whatever that is, bringing it up. In this case, he has to be able to bring it up, which is to say they have to stick together.
Okay.
Okay.
Amino acids are soluble in different solvents.
Why would you add in the solvent, right? Okay, yeah, in the solvent. Yeah.
Which again.
Oh, let me see the reaction. Okay. Oh.
Let you see. Um, 3.
What happened in 1A? Sorry. What happened in 1A? Sorry. 1A
One,
is?
one
2A, sorry. 2A, sorry.
each amino acid is soluble to different extents in the same solvent, which makes sense. Because I didn't allow their separation.
The separation. No, you are correct. No, the answer key is correct. Yeah, the way the ability of the solvent to stick to the amino acid are different. So they are carried differently. Yeah, correct.
Yeah.
Excellent.
What's a locating agent example?
Yeah, that part I'm very right. So meaning to say, whatever that locating agent means, he has to make the colorless become, well, not colorless lah. So colorful.
Right? Yeah, so that's correct. That's fine.
I don't think we will learn what is the locating agent, I suppose. It's just that the locating agent has to be able to stick to different amino acid, but yeah, so give them different color or something like that. Is different color strictly necessary? I'll loosely say no, just have to, but no, I don't know the exact name or the exact formula for locating agent. No, I just know what they're used for. Okay. Meaning to say you don't have to know. Sorry, you don't have to. Sorry. Yeah. Practically.
Okay, then I also got 2C wrong, which was, I mean, again, it makes sense. Compare each RF value against theoretical RF values of standard samples of known and pure amino acids. Okay, that does make sense.
I suppose because chromatography is a very standard procedure, like you have to use this solvent, you have to, that makes sense. That makes sense. No, that makes a lot of sense. It is a standardized thingy. Makes sense, makes a lot of sense. Yeah. I guess they will expect you to say that. I mean, it makes sense for them to expect you to say that. Wait. Not every lab chromatography are done that way. So when you do your chromatography in the lab, so did you ever done it?
No.
Oh, no wonder. Because my next question is, did you do it, when you do it in the lab, do you have an impression that it's a very standardized thingy?
No, I didn't.
Yeah, okay. So I guess we learned something. Okay. Can we break half an hour, then we start again?
Sure.
All right. I'll see you later. Yeah.
Okay, bye.
Bye. Anish, can you hear me?
Yeah.
Good. Okay, I can hear you. All right. Oh, you were doing some things, right? Any question? Oh,
No.
all right. So you are at? Oh no, you're still at 2. Sorry, 2, right? Would you like to focus on the mole question? Because we only have 1 hour left.
I think I can finish the whole paper, and or maybe like a bit more. I don't remember. I have four.
Based on your current speed, I think you can do at most 4 questions. That's maximum.
10 minutes for that's 6 questions. I think I can. I think if I hurry, I think I'll do 6.
Okay, right. So are you going to choose them? Because doing in order doesn't necessarily mean the best thing. I mean intuition, right? You say have tuition, so maybe you want to choose your questions.
Okay, how about while I do question 3, you choose which one I should do in order to improve my.
The more one? Oh, no, the guess one, right? I think you should do question 9.
Okay, I'll do question.
Do 9. You should do question 8 just to make sure. 9, 8. 9, 8, 5. The rest up to you. Up quickly.
Okay, I'll do question 3 first. Since I've already read.
Okay.
Okay, I'm gonna check the answer.
Oh, yes, please. Oh, it's only 3. Oh, all right. I don't think you should say different masses. Did the answer key say that? It should be different density.
Yeah, you're right. I got 1 out of 2 marks.
Right.
But density is 1. Density is the other mark.
Yeah, so mass is wrong concept, wrong usage. Density
No,
is
it was
correct.
mass. It's correct. Relative atomic mass being like the fact that LR103, IR103 has a higher atomic mass per unit volume is. Oh, I did put per unit volume.
When they say per unit volume, that means density. If that's how they phrase it, mass per unit volume, that's just the same as density. So the mass is wrong. In that sense, it's incomplete. Incomplete.
The 2 marks, the first mark was that it has lower density. And the second mark was because its atomic mass is lower per unit volume.
So yeah, you cannot use mass.
Yeah, so use per unit volume.
Yeah, right. Yep. Okay. All right. Okay. Go to 5, please.
Okay. Joseph is a very keen guy, very proud of his God. One day he wrote some nonsense from a nursery. What in the world is this? Oh, I actually have no idea. I don't know what to do. I think we have done something like this before.
What is the topic? The topic is wait. Oh no. You wait. No. Wait. So again, it's a mixture. All right. Okay. Okay. So the claim is 30% sand, which is people say it's useless. More like it's a filler. Like it's okay, but his mother say that it is a lot of sand and not enough fertilizer. So that's definitely cheating. So
I know sand is a giant covalent bond, but I don't think that's relevant.
Fair enough. I mean, you can test the sand. That's what you're saying.
By higher, like, because giant covalent has higher melting boiling points. So if you were here and I came up with this question in exam, that's what I would write.
You will use higher melting point to test the sand, really?
Yes, but I don't think it's correct.
Yeah, the melting point of sand is around, I don't know, 1,500. Yeah, so you're describing something which is not practical to be done by Joseph.
As in,
a simple experiment.
The melting point of the fertilizer. See, after the fertilizer is all melted or boiled. Sorry, melted, yeah. After, like, I'll see which one melts first. And if the fertilizer melts first, then I'll see how much sand there is left. But I don't think that's the correct answer.
Yeah, most things don't melt. Being very practical, most things don't melt. Most things don't melt in a way that we can do it. Again, simple experiment. I think if we have a complete equipment, we can do that. But this is my nice way of saying that no, I don't think so. Right? Okay. So you don't know what is sand, and only at B he knows what's the fertilizer. So it is assume at A that you don't even know what the fertilizer is lah. How are you supposed to do this? Okay, right. Yeah, you don't know what's the fertilizer, my goodness. Right. Okay, I'm going to cheat, yeah, we don't have much time. So I'm going to assume that he knows the fertilizer. At the very least, the packet should say what the fertilizer is. In this case, it's ammonium nitrate. So I'm taking information from B. This is not supposed to be how we do the question. Yeah, we're supposed to assume, so I don't think so. Right? But if we just use water, it will be very simple. Now, at least we know that sand sinks. We know that. We know the what? Sand sinks in water. At least we know that. Yeah, okay. Right. So that's our experience, the experience from the beach. We can use our common experience. Right? Even though you don't know what sand is, you know that sand sinks, but it is not guaranteed that fertilizer will float. Because if the fertilizer float and the sand sinks, that's a very easy way to separate them. Yeah. Once you separate them, you can measure the whatever by mass or by volume. Now, however, since the fertilizer is ammonium nitrate, which is a very bad fertilizer, it will dissolve. How do I know that ammonium nitrate will dissolve? Because is it in the table? You need to consult that immediately. You need that tomorrow. That should be your instinct right now. Ammonium. Yeah, anything to do with ammonium dissolves. And anything to do with nitrate also dissolve. So both, yeah.
So
Right,
the double. Yeah.
Yeah. So it will dissolve. So if I cheat a little bit and notice that the fertilizer definitely will dissolve, then I will find out how many dissolve, and then I'll throw out the water. I can measure the remaining sand. That's how I will separate the sand and the fertilizer. Just to be clear, this is clearly a separation question.
Yeah, separation techniques, yes.
Right. So I would like to separate sand from fertilizer. How do I do that? For example, that's how I will construct this question in my mind. Right. Again, I'll just measure the sand left behind compared to the original mass.
Wait,
So very simple experiment.
Follow. What technique are you using?
I measure the original mass. Easy, right? That's something easy to do by Joseph, right? Then I put it in water. Sand do not dissolve in water, so I'll use that instead. But fertilizer dissolve in water.
How do you know fertilizer dissolves in water? I think we should run through the separation techniques and then see if one applies in here.
Yeah, if we don't know what's the fertilizer, we cannot do that.
I mean, okay, we have filtration. Filtration does work.
What are you talking about? If we do know what the fertilizer is, we do not know what technique can be applied. It's not the technique problem. It's the we don't know what it is problem.
But will filtration not work? You said the filter paper, and then the sand will be left behind.
And the fertilizer will go through. Why would the fertilizer go through? Because it dissolves, right? I mean, they are both solid originally, right?
Yeah.
So why would the fertilizer go through the filtered paper and the sand does not? If it is not, it is not dissolved or it is not in the liquid form. I thought filter paper is used to separate solid from liquid, something like that.
Yeah.
Right. So do you stand by that?
I guess, yeah. Like, I don't stand by it.
Okay. But I'm not saying that I know what it is if I don't know what the fertilizer. That's my biggest confusion. I'm as confused as you. Let's just put it that way. Okay. Now we don't have much time. I have concluded my discussion. That will be what I wrote. I'll cheat a little bit. I mean, if I don't feel comfortable cheating, I'll say Joseph should test whether the fertilizer can dissolve or not. That's half cheating, no? Oh, if the fertilizer, okay, I have to cover my, backside, right? If the fertilizer dissolve, he can then proceed to do this, something like that. That's a very simple experiment that Joseph can do. So I'm staying within the boundaries of the question. Would that be okay? Now, we don't have much time. Do you have any other opinion? You must go put it out first, and then we just see the answer.
No, I think what you said is correct. I think I should just check the answer.
I don't think I'm correct. I'm cheating. That's what I said. No, please,
yeah,
let's look at the answer.
That's the best effort I would have done.
Yeah, come, let's look at the answer.
Wait, no, I was right. It's actually a mix of both.
Come on, say it up.
Okay, so I'll read out the whole thing. So it says measure 100 grams of the lawn sand. And then add water and stir thoroughly to dissolve the fertilizer.
See?
Yeah,
he doesn't even bother to justify, right? Then?
Yeah. And then filter the mixture, and sand will be the residue. And then
yeah, and then you just measure the sand mass, and then you find out sooner. Right?
No, okay, there's two ways you can go from after filtering it. The first one, evaporate the filtrate in the evaporating dish to dryness to get dry fertilizer. Ammonium nitrate sublimes, correct?
No.
But what's sublime?
No, they don't. They crystallize.
Ammonium chloride sublimes. To evaporating dish to dryness to get dry fertilizer, measure the mass of the fertilizer collected in the evaporating dish.
Yeah.
That's option one. Option two was to measure the mass of the sand on the filter paper. That's the simpler one.
Yeah, the simple one and the less accurate one, which doesn't matter for Joseph. I don't think so.
Yeah.
Right. Okay.
Then compare the mass of the sand fertilizer against original mass of lawn sand.
To check that's by logic. Yeah, that's by logic already. Right.
Okay, so you were right. Yes.
Okay. So
Yeah.
I would bother to justify my cheating lah. I'll bother
Yeah.
somehow. Right. So can you do number 2, please? B, 5B.
Okay. Calculate the number of formula units present. Mole. What is a formula unit?
I have absolutely no idea. What is that? Let me think carefully. Just calculate how many mole there is, and then we'll just look at the answer key. I don't think that's the case, but we don't have much time. I've
No,
never heard.
I have the solution in my notebook. Like I quite literally have a model solution for the question.
Which is, what is formula unit then?
I'll show it to you. It's over here.
Oh, goodness me. It's how many molecule? Why would they use the term formula unit?
I think that's just something they taught the class, and I just.
So you calculate the mole, right? Calculate the mole, standard thing, right? And then you will times that with the Avogadro number, lah.
Yeah, if I calculate the mole equals to mass over mR. Did they give us mass and mR?
They give you mass, right?
Oh, okay. Yeah,
they also give you MR because formula, lah. Then you just try that first while I check what is the term formula unit. I have never heard of that before, yeah?
Yeah.
Okay.
Was that correct? Can I just search up the MR?
Let's just try, okay? Let's just try.
Can I just search up the MR for this?
Yeah, be quick.
Yeah.
Yeah. Half an hour.
18. Again, Google is confusing. I'm gonna do it properly myself. 14, 18. Plus 14 is 32. I'm gonna check the answer.
All right.
SF. SF is actually a very important thing. I always forget about it.
All right.
So I got it. The answer was 1.51. I put 1.505.
Correct. There is no unit in usage here, right? Just like that.
Yeah.
Okay. Right. Okay. Let's move on to question 8 and then question 9. I think we'll have just enough time.
Okay. Question 7. Okay.
Question 7. No, question 8. Question 8.
Oh, I was reading the wrong. Okay, I'll do question 8.
Right. 7. I was choosing between 7 and 8. Just do 8 first, and then 9, and then you may want to do 7 lah.
Okay. If an alkaline formula X is to X to 2. I hope there's a lot of balancing questions because I'm actually okay. I'm quite good at it.
No, it will be just one. It will be just one.
Yeah.
Really, it will be just one.
Calculate the number of moles of hydrochloric acid used in the reaction. How do I do this now? Number of moles. Do I? What do I do with the also number of moles?
Okay. So
what does number of moles mean?
what do you mean by number of moles mean? The number of mole is how many mole? What do you mean?
So just find the mole value.
Yeah, the mole that we mean as in how many mole, like 1/4 mole. In this case, 1/4 mole in 5b, that's the number of moles.
Oh, okay.
All right, okay. All right, can we have a move?
Yeah, I'm reading the question.
All right.
It's volume, concentration.
Now, it's the strangest thing, but you will need, sorry, how many SF are you supposed to?
3.
0.0925 is 3 SF.
The 0 before the 9 is not 1 SF.
No, at all.
Okay.
You need the unit, I believe, just to make sure, just to make sure, just to be certain that you're doing it that way, the way that they want it. Just write the unit. The working is fine. I'm talking about the final answer.
Okay. I'll fix the working. Just realized. Yeah, your unit thinks so.
Okay, good. The answer is 0.27, really?
0.270.
Okay.
270,270. I think with the upper zeros.
Yeah, because if you need 3 SF, then you need another guy behind. Right? Okay.
Still very clear, not very clear on the SF.
The 0 behind is always significant. The 0 in front is never significant.
That actually doesn't logically make any sense. But
that makes a lot of sense. Oh goodness, we don't have time to discuss this. We don't really. I'll discuss it with you after the exam. Okay.
Okay.
Okay. The 0 in the middle.
That's
Good. Good. At least that's good. Okay. Would you kindly finish C and then we can look at the answer.
gram over DMQ. Where did they get gram from?
Does it bother you that the unit you have never seen before? Gram over DMQ?
Yeah.
Why does it bother you? It's gram over DMQ.
That's what mass over concentration. Sorry, mass
No,
over
volume.
volume.
Yeah. That's it. That's it.
But where did they get the mass from?
What do you mean? They give you a concentration. Concentration is not mass. It's gram over DMQ. If you want the mass, you can. If you want the mass, if that's what you mean.
That's what they want, right? Relative molecular mass.
Yeah, so if you want it, it's not very complicated, right? You have gram over DMQ.
So just multiply your DMQ.
Yes, that's it, right?
Oh, that's the answer? Okay.
That's the mass lah.
That's what they asked for, right? The relative molecular mass.
Why do you keep saying that relative molecular mass is mass? Sorry, why do you keep saying that? I noticed that at 3B, but I thought it was a misunderstanding. I misheard it. Why do you say that relative molecular mass is mass?
Is it not?
Ah, shit. Okay, relative molecular mass is MR.
Oh, what? Okay.
Mass is mass. Relative molecular mass is MR. Let's stick to that for now. We don't have time to explain.
Okay, let me write it down. What does being titrated against me?
Titration is doing it slowly, right? Tick, 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 tick. Why are we doing it slowly here? There's a reason.
To get the precise volume.
Or because we're trying to neutralize the acid against the alkali, right?
Oh, I thought the emphasis was slowly. Yeah.
Yeah, because we want it to be precise, but the point is we're trying to neutralize. If you over titrate, you are no longer neutral.
Yeah.
If you under titrate, you're also no longer neutral. That's not titration. Does that make sense?
Yes.
All right.
There is no element with 171 MR. Did I do it wrong?
Element.
Could
The
be.
MR is for XOH2, right?
Oh yeah, right. Yes. Okay, that does see. Okay.
Okay, better.
Nope, still no MR for 1.2.
Right, because you're doing it wrongly. Ayo, why do you do it that way?
Oh, what did I do wrong?
I'll give you 30 seconds. The process is correct. You're being careless. 30 seconds.
Is the calculation error?
No. Okay, 30 seconds now. Why do you do 80?
Oh, Jesus Christ. Okay. 30.
Did you get any possible X then now?
137. Yes, I did. It's barely.
Good. Right, checking the answer key.
That's it's correct.
Good.
7. Yeah, because 0.270 is correct.
Wonderful.
I didn't do CI. What? I did just skip a question.
CI, there is no CI, so you see
Yeah. Let's just
five,
talking about.
5 months.
I'm not sure what this question is talking about, but
Right. Okay, let's move on to question 9. Let's move on to question.
a student conducted an experiment according to the flowchart showing aqueous ammonium carbonate. That's what are the scared carbonates and scared acids? I'm not scared acid is H2CO3.
The coward, yeah, H2CO3, the carbonic, and the cowardly alkali is the NH4OH. Would you please write that down? You need that tomorrow.
Yeah, NH4OH. Okay.
That's the cowardly alkali, and the cowardly acid is
Okay.
H2CO3. Given a chance, he will not become lah.
What will they for? I don't have this written in the old one.
Okay. Are you ready to identify A, B, C, D?
But the old Jamboard actually had a lot of empty frames.
Empty frames?
The old Jamboard, but yeah.
Okay. Empty frames. Okay.
Plus S.
That's weird. We don't have much time, huh? So are you doing it my way? What is my way?
I'm adding them up and then doing it. Yeah,
No, the positive and the negative. The positive and the negative of ammonium carbonate, the positive and negative of sulfuric acid.
Yeah, that's my way as well.
Good, good. It's NH4 plus, okay? NH4 plus, then CO3, 2 minus, you'll need it tomorrow, yeah?
Okay. And then H2CO3 breaks up from hydrogen for water and carbon dioxide. So A is water, C is A is carbon dioxide, B is water.
B is water.
Sorry, B is a salt, so it's salt with NH4 too. Oh, there's only 2 marks. This is 14.
Stop complaining quickly.
Yeah. Sodium hydroxide.
Anish, why do you start with NaOH and you get NaOH again?
Sorry, it's not NaOH, it's NH4OH, which produces ammonia. Water.
That's the cowardly guy. That's the cowardly guy. It's not ammonium, it's ammonia.
Okay, so
NH3, NH3, NH3. Yeah, NH3 is better.
Yeah. And D is NH2. I'm gonna check the answer immediately.
Yep.
Ammonia, gas. I didn't mention that, but they already said it's gas. I don't think it's so sulfate, sodium, carbonate. Okay, it's correct. Actually, if anything, they niced me because I didn't have to write the formula.
Please write the formula. The English is inferior.
Yeah, I know. I'm just saying that the answer sheet didn't put the formula. So that means
Sure.
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 What are the tests for hydrogen, carbon dioxide, and ammonia?
What are the tests for carbon? Wait.
I'll recap. Hydrogen is putting lit stick into the hydrogen gas, and then if it pops, it's hydrogen, right?
Mhm.
Then carbon dioxide is bubbling it into lime water, choking is carbon dioxide.
Mhm.
And pardon me, ammonia is if you put red litmus paper to it, it becomes blue.
Wet litmus paper.
Red litmus paper.
Yeah. Mhm. Right. Going to C and then going to D.
Yeah. That's for ammonia gas or ammonium solid or something.
There is no ammonium solid.
Or like mixture.
Yeah, ammonia gas, please. Ammonia gas.
So you put ammonia gas to the litmus paper.
Yeah, or you put the red wet litmus paper into the whatever container that contains ammonia gas, because you learn how to collect gases,
Okay.
right? You can use a collection and then you do that.
Ammonium carbonate. I've already done this.
Sorry, you're saying?
I've already done this.
I'm so sorry, I cannot hear you. Sorry, you're saying?
I've already done this. So
You have already done this? Part B, you mean? No, part C.
yeah. H2. And H4.
Balancing.
Yeah.
Wait. Pull up. Hold up. Let me see. Wait, what? When I'm looking for what? Why would you? You make a mistake in your balancing, yeah?
I didn't. You can ignore the bottom ones. It's this.
I know. The bottom one is the best thing ever. Lah. So again, I make a mistake. That's it. That's the correction.
Yeah. Yeah. I confused myself.
Are you sure that's the only correction? Okay, time is almost up, yeah, so we'll be very quick.
This is one as well. This is nothing that's two.
Right, now I have a very important question before you look at the answer key. Does your teacher ask you to do ionic reactions or ionic equations?
No, I asked this in class and she said no.
Okay, wonderful, thank you. So please check the answer key.
What does it do?
No, stop. You don't have time. We don't have time. Look at the answer key.
9. Correct. Yeah, whatever I've done is correct. I mean, I did know the moles part, which is important, but yeah.
Now time is up. Tomorrow is chemistry test, right? Tomorrow is chemistry test in the morning, is it?
Yes. Sorry, you didn't mean ionic bonding, right? What did you mean?
No, ionic equation, where the equation is simplified. Where the reaction is simplified.
Yeah. Okay. Like, as in, reaction is simplified. Does that mean? Are you talking about?
I'm going to do that for you, and then you decide whether it is in or not. I'm so sorry. Yeah, that is part of your weakness. You sometimes don't know whether it is in. Okay.
No, wait, do you mean empirical formula?
No, I don't mean that.
Oh, okay. Yeah.
Do you want me to do it or not?
Do what?
Do you want me to show you what an ionic equation means?
Sure.
Okay, page 2. Tell me when you're there.
Yeah, that's an ionic equation.
No. So I'm going to use this. Okay. I'm going to use this, and then this guy, I'm going to split again back to this.
Wait, sorry, is this tested?
I'm asking you. You cannot ask me.
Oh, no, ionic equation is not tested.
Okay, then let's ignore it.
Yeah, okay.
Okay, tomorrow is the exam at the morning, right?
Mm-hmm.
Do as much possible you can by tonight. Then you have to sleep. All right? Let's say. Try not to sleep beyond 11. And then physics is the next day.
Yes, I'm very, very worried for physics, but I don't think I'll be having tuition with you on Tuesday.
All right.
Unless I have some questions to ask, maybe I'll just pop in at like 9:30.
Sure thing. Okay. All right. I can still answer your question tomorrow morning, I suppose, if you want to send me for chemistry.
Sure. When are you going to sleep?
The latest is 1 hour from now.
Okay.
All right.
Okay, then good night.
Good night, yeah. I'll see the WhatsApp, okay, before I sleep. All right. Okay.
Okay, bye.
Bye.